You see someone throw trash onto the beach, and your instincts tell you to pick it up. However, there's no incentive to pick up the trash, so nobody picks up the trash. So we thought, what if we can create an AI solar-powered trash cleaning robot?
With this solution in mind, we plan to solve the 11th goal of the SDGs, sustainable cities and communities. And so, my teammate and I established Formosa Blue, a newly established startup group created by 2 high school students that aim to utilize our amateur engineering skills to solve issues of the environment. And this is our journey of how we created our first physical prototype. So how will our solution work? Well, let's talk about the AI aspects first.
So if this was our car, it would need to be able to identify and move towards the trash to pick it up. But how could it accomplish its goal? And the answer to this would be AI object detection. So after I made my model, where can I find the data to train on it? So I went on GitHub and found the Taco dataset, which has thousands of images in more than 60 subcategories, all well formatted, most suitable for our training process. Finally, I went onto my laptop and wrote quite a bit of code to train our first model at last. After 2 hours of training, we can finally get our hands on this brand new model that I named first version. As you can see, it will be able to detect my water bottle, the Coke can, and plastic bag behind me with ease. However, it still lacks of the ability to effectively lock on targets that are moving, which is a bug we could possibly improve from in our future.
Now let's talk about our car's mechanism design. We used Onshape to create 3D CAD models of our prototypes. For our first prototype, we thought of using tank-like tracks for the car to be able to travel over different types of terrains. We also thought of placing a robotic arm at the front of the car in order for the robot to pick up the trash and place the trash behind the car. However, we later realized that the tank-like track system consists of multiple complex structures, such as the suspension and multiple track pieces that could take up a lot of time to assemble. So we redesigned the car and created the second prototype. Wheels are used instead since the structure is more simple. Furthermore, the shovel-like mechanism in the front of the car will be used to pick up the trash and place it in the bin behind it. On top of the car, solar panels are utilized to charge 3 18650 rechargeable batteries, which powers the Arduino board, the brain of the entire car,
And the motor controller chip. The Arduino and the motor controller chip sends the signal and the battery power to the 2 12-volt DC motors that turn the rear wheels and the 2 servo motors that control the shovel-like mechanism.
Now let's talk about how we brought this prototype to life. We bought several different types of materials. The Arduino chip is the main control center of the entire car and controls the car's motor movements for the wheels and the trash picking mechanism. Wires, which are much needed, connected each component to each other, sending signals and power simultaneously, creating an effective electrical circuit system for the vehicle. Other components also include the wheels, motors, motor controller chip, nuts and screws, soldering pin, and other necessities. After getting the materials, I then went back to the 3D CAD model of my prototype on Onshape, focused on the chassis of the car, which is shaped like a box. I then exported the 3D CAD file as a 2D blueprint, and used the laser cutting machine to cut out the desired pieces using wood. I later assembled these components together, which resulted in the vehicle looking like the photo shown above. We then tested out the vehicle, and it ran pretty smoothly. The solar charging battery power system and trash picking mechanism were also added. Then, we tested if the trash picking mechanism worked, which also did, kind of. But this was just our first physical prototype. And this is just the first stages of the project. So how will this impact the society? Cities are rapidly advancing in technology and building higher quality infrastructures to improve the lives of the people. Waste will be inevitably produced and scattered across the city. With our newly developed AI solar-powered trash cleaning robot, Goal 11 of the SDGs, sustainable cities and communities, can be solved effectively. This can not only be part of the city's technological development, but also clean up the city and maintain a sustainable and environmentally friendly place for everyone. Now let's talk about our future plans and further implementations. Firstly, let's talk about the structural design improvements. Our first physical prototype's trash picking mechanism uses a shovel-like mechanism that does not have a guaranteed success rate of picking up the trash every single time. Therefore, we plan to later create a second physical prototype similar to the first 3D CAD prototype. This will include a proper robotic arm, a proper chassis modified from a remote-controlled off-road toy car made of aluminum, allowing the vehicle to be sturdier while having a higher chance of picking up the trash successfully. We also plan on fully implementing AI on the vehicle's control system, which allows it to not only identify the type of trash using a camera, but also use the camera to send signals to the vehicle's central processing unit to turn the motors and steer the vehicle to the direction of the trash and picking it up. We plan on doing this by utilizing the Raspberry Pi, a low-cost, small single-board computer that can be used for a wide range of projects. This microcomputer can provide us with the ability to do nearly anything we have in our minds and bring these ideas to life with our engineering and coding skills. Lastly, we plan on creating an online website in the near future to track our AI trash cleaning robot vehicles and record how much of each type of trash had each vehicle collected. This domain will not only allow the public to see the impacts of our invention on the environment, but also report any issues to us if a vehicle stops functioning properly. Finally, the risks and challenges. Previously, we've encountered challenges of the motor controller chip short-circuiting and the Raspberry Pi microcomputer failing to boot up, rendering the device useless. Possible challenges that might be encountered in the future include difficulties in modifying a remote-controlled car and a larger sum of money lost when mistakes are made while utilizing more expensive tools and equipment. If possible, we plan on reaching out and collaborating with Taiwan's major RC car manufacturer, Thunder Tiger, who also happens to be innovating in future forms of transportation. Once the final prototype is deemed successful to perform all the tasks stated previously effectively, we plan on creating more units of these AI trash cleaning robot vehicles. After that, these vehicles will be placed in areas close to us in Taiwan, our hometown, such as in our school, on a nearby beach, and maybe even our nearby parks to be utilized in the real world. This makes maintenance and tracking easier for us too, since we can travel to the area more easily and fix the issue if one occurs. This can not only make our societies cleaner, but also, if successful, attract businessmen to make it more accessible for the public, ultimately achieving the 11th goal of the SDGs.